All right. Okay. If 100 milliliters of 0.001 molar lead nitrate is added to 400 milliliters of 0.02 molar potassium iodide, will a precipitate form? Okay. So, if a precipitate forms, can you guys tell me what your precipitate will be?
Let's look.
Lead iodide.
Lead iodide. So really what you've done in your head is you've done a double replacement reaction, right?
Because nitrate is insoluble, so lead would have to go with the iodide.
Exactly. So if you did a double replacement, you'd have potassium nitrate plus lead iodide. Well, all nitrates are soluble and all 1As are soluble. So the potassium nitrate is a dud, right? So the precipitate would be lead iodide. So we are going to start this like I start every problem. What's the first thing we're going to write?
The reaction.
The reaction. Very good. So PbI2 as a solid can dissolve a little bit into the lead ion and the iodide ion. Now, I know that we're talking about kind of the reverse reaction. We're talking about if you put this ion in and put this ion in, will a precipitate form? Okay? But we still write the reaction in this direction because one of the tools, the tool we have to work with is KSP, right? And KSP is always in this direction. And our KSP expression is lead to the first and iodide to the second. Okay? All right. So now, here is what I want you to kind of refocus on. We said earlier that when we have something insoluble in a beaker, most of it might sit down here. So here's the lead iodide. But aren't we saying here that a little bit of it might exist in the dissolved form? Okay. But isn't it this telling us that there is a maximum amount? There's a maximum amount of these ions that can exist. Y'all see that? And that maximum amount would be what you need to make a what type of solution? A saturated solution. If you have more than those amounts of ions, what's going to happen?
Supersaturated.
Well, it'd be nice if we could make supersaturated, but don't we have to like heat it up and go through extremes? So instead of getting supersaturated, what will it do?
Unsaturated.
It'll just precipitate, right? If you have any extra ions, it's just going to precipitate those out until you get to the right amount, the maximum amount. Is everybody with me?
Yes.
Okay. It's real important that you understand that.
Yeah.
Okay, so here's the deal. All we have to do for this problem is to see if we have the maximum amount of ions or not. If we don't, if we have something smaller than the maximum amount of ions, then will we have any precipitation?
Nope.
No, because they'll fit in solution. If we have more than our amount of ions, will we have precipitation?
Yes.
Yes, because you have more than will fit. So that's all we have to do. I have to plug in a concentration here, plug in a concentration here, do the math, and compare it to the K value. Okay? All right. Everybody good? All right. So now what we're going to do is we're going to figure out our concentrations of each ion. It's a little bit more work than just putting in these numbers because when we add two solutions together, what are we doing to the other solution? Making it what?
Wait, repeat the question.
Did you say it, Star? What did you say?
You're diluting one and making one more.
It's that first one. Star's right. We're diluting it. If we're going to have, here we had 100 mils of lead nitrate, but then we're going to throw in 400 mils of something else. So we're changing the volume of lead nitrate from 100 to a total of what? 500. So if we're upping the volume by a factor of 5, guess
Less
what we're doing to the concentration?
Decreasing.
We're decreasing it by a factor of 5. Okay? This is how I like to do it. Some of you might do it a slightly different way, but I keep track of each ion. So if I'm keeping track of the lead ion, I first write down that I have 100 mils, or 0.1 liters, of 0.001 molar lead nitrate. Okay? And the lead nitrate gives off 1 lead. So I'm going to focus on that. So 0.1 times 0.001, that's right. So I have this many moles of lead. But I can't plug in moles here, so what am I going to do to that number of moles?
Over liters.
Now I'm going to put it over liters to get my molarity. But now, instead of this many moles of lead just floating around in 100 mils, how many total mils is it floating around in? Total mils. 500, which would be 0.5 liters. Okay? So we go ahead and do that. And we get 2 times 10 to the negative 4 molar, and that is going to be our lead concentration. Okay? Let's do the same thing with the iodine. Okay, let's take our, in this case, 0.4 liters of 0.02 molar, and the potassium iodide just gives 1 iodide. If it had been like something I2, then we would have had to compensate by multiplying this by 2. So 0.4 times 0.02 is 0.008 moles of iodide. And so now what do I do to that number?
Divided by 0.5 liters.
Again, divide by your total volume. And these numbers should be the same because you're mixing everything together. So you get 1.6 times 10 to the negative 2 molar of your iodide. Can you stop it for a second? Okay,